Okay, for number 3, it's a fourth degree polynomial. I'm expecting to get 4 roots. There's all kinds of things we could do. I get upper bound, lower bound, how many positive roots, how many negative roots, yada, yada. We've done a lot of work with these things. I'm really going back to, like a primitive skill set, and that's the rational root theorem, or what some people call trial and error. And it's in a beautiful form, by the way. You can easily write it down, what the candidates are. It's a long list, though. How many numbers are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 16 different things to test out. Yeah, my claim over here is 1's not going to work out well, 2's not going to work out well, -1, -2, not going to work out well. 4 works out well, and by the way, I'm exhausted at that point. So I know that x minus 4 is a factor, and since I'm exhausted, I go straight to long division, and I get this depressed cubic over here. Now, what's nice about the depressed cubic, it's actually simpler to deal with. And by looking at this over here, the depressed cubic, I find it, easier than a fourth degree, so I kind of peck at that one. And looking at it, I'm looking for easy, rational roots. 1, well, I don't think I'd go for 1 because I just tried that. I wouldn't go for -1, I've tried that. Plus or minus 2, I wouldn't try that. I'd probably start out with the 4 again. And 4 was successful last time, maybe it's successful this time, and it is. So what I've found over here is x minus 4 is a repeated root. All right, what's left over is a quadratic, though, and I got that by division right over here. All right? So then you look at that and say, how could I solve that? By the quadratic formula, and you're looking for the zero net. You're not going to get that with the rational roots, by the way. You've got some nasty numbers, and those numbers are over there. So there's 4 roots. We found them all. Some are repeated. For example, write this down. You got 4, 4, and then we found -4 plus 2 root 2, and we use quadratic formula to find that, by the way. -4 minus 2 root 2. 4 roots. All right, and I also approximate those for you. Right, that's the way I'd go through the problem. There's no doubt about it. We provide a picture for the people who want to look at the picture. Euler's method, though. Let's go through it. And it seems like it's tough. It really is. All right, am I doing the right problem? No. Yeah, I think so. So, -40, that's A. This is the B. That's the C. I get back that cubic, which is always easier to deal with, by the way. And I get by inspection. And then what I do is I further depress that cubic to a square, and I get this over here. So I'm really getting a bunch of answers over here. And what answers I'm getting? Well, the roots to this thing are going to be 2, 16, and 2. Right? What do you do now? Well, you're going to write it down. All right? And you're going to write that combination thing down. And certainly you're going to get the same solutions to the problem with the repetition, by the way. Again, what do I find easier? I actually find it easier to do the rational root theorem. I really do. Right? Even without a calculator. This is doable, though. You should study this thing. And certainly if you're studying that section of the notes, give it a good deal of thought. It's worthwhile. Euler's name's attached to it. That fact alone makes it worthwhile. All right? Thank you.